Okay, thanks first of all for inviting me to speak here. My name is Tim Drafts, indeed, and I'm a PhD candidate at TU Delft, and I'm going to talk to you about the cognitive biases in crowdsourcing checklist and how to apply it. Specifically, what I plan for this talk is to actually discuss two separate papers. One from HComp last year, where we proposed this checklist that I will be talking about, and then one from FACT this year, where, among other things, we applied the checklist. So I thought I could describe it here to kind of present a use case showing how the checklist can be used in practice. But first of all, what are cognitive biases and how are they actually relevant in crowdsourcing? Cognitive biases, you've probably heard about this term already. They have been known in the psychological literature for decades already. People actually got the Nobel Prize for it, for discovering them. And cognitive biases are basically human tendencies towards irrational decision-making. All humans have them, including crowd workers. And recent research has shown that these cognitive biases can really negatively affect data quality for crowdsourced annotations. And just to give you an idea of what that might look like, let's say we have a simple annotation task where we ask workers to label images, such as this one, as a paella pen or not a paella pen. In this case, this is actually a risotto pen. So it's not a paella pen, but suppose we would, for instance, show to crowd workers how many other crowd workers have labeled this pen as a paella pen, and for some reason this proportion is quite high, then research has shown that crowd workers can fall prey to like a groupthink bias, or sometimes called the bandwagon effect, where they think, okay, based on this information that many other people think this is a paella pen, I'm also going to say it's a paella pen, even though they are wrong. Or for instance, you can think about something like the affect heuristic, where a worker might think, okay, I really like this pen, and I could, imagine cooking a paella in this pen. That, of course, doesn't make it a paella pen, but there can be biases where just based on workers liking or not liking an image, they alter their annotations. This is an actual paella pen, by the way, just in case you were wondering. So, as I said, cognitive biases have been shown to cause poor data quality in crowdsourced annotations. And this is, of course, a problem we would like to alleviate. And it might be quite a big problem. We did, in this HComp paper that I mentioned, we did a sort of retrospective analysis of past HComp papers from the last few years. And we found that cognitive biases may have played a role in really a majority of the crowdsourcing tasks that were described there, but very rarely cognitive biases were considered by the authors, by, for example, mitigating cognitive biases in a targeted way, or even just discussing them in the paper. And we thought the reason for that was probably that cognitive biases are just kind of hard to deal with. Sort of a complicated, perhaps, concept from psychology. I think more than 180 cognitive biases have been identified in psychological literature. So it's really a vast space, and it might be quite unclear to request us, what cognitive biases may play a role, in what way, and how to mitigate them. And we thought one way to reduce this complexity would be to introduce a checklist, a simple checklist that has 12 items. Each item concerns one specific cognitive bias or a group of similar cognitive biases that are sort of the most common one or the most concerning ones. This checklist was actually adapted from a similar checklist that had been proposed earlier for the business decision-making use case, and we sort of adapted it to fit this crowdsourcing annotations use case. And so the idea is that requesters can, ideally before designing the task, or at least before collecting data, go through this checklist and just kind of decide, okay, does this specific cognitive bias, for instance, the group thing that we were talking about, can this affect crowd workers in the specific task I'm about to launch? And in the checklist, we discuss also a few examples, and we ask basically targeted questions that that the requesters can directly evaluate with respect to their task. Doing that, we imagine that the checklist will enable requesters to do mainly 3 different things. First of all, it will enable them to measure or assess cognitive biases in their tasks. So, for instance, if I'm worried about the affect heuristic that I mentioned, one thing I could do is aside from the labeling item for crowd workers in the task, I also add an item that says, okay, to what degree do you like this pen that you see here in the image? And later on, I look at the relationship between how much crowd workers liked the images that they saw and the actual labeling. Aside from that, of course, it also enables requesters to design and implement mitigation strategies for cognitive biases. Some mitigation strategies have already been proposed in earlier work. And then, yeah, sort of as a minimum requirement or a thing that any requester can do, even if the data actually had already been collected when going through the checklist, is to document the potential influence of cognitive biases so that people who use the data or somehow build on it can get an idea of its reliability and, well, what kind of biases might have taken place that reduce data quality somehow or in some systematic way. Okay, and to show you how this checklist can be applied, I thought I quickly go through this study we did for our fact paper from this year. There we looked at crowdsourced fact-checking tasks. So as you are probably aware, fake news is a really big deal at the moment, and that is why many requesters are currently collecting annotations for documents regarding the truthfulness of all different kinds of documents. And what we wanted to find out in this project was what kind of worker biases and also specifically cognitive biases can affect crowd workers in this context, so that they can then be mitigated in some way later on. Our starting point here was an exploratory study that we performed on a public data set. This data set contained 180 politician statements that each already had a ground truth with respect to whether the statement is true or not, because they were retrieved from fact-checking websites. But in addition to that, they also contained extra crowd annotations. And all of these annotations in the ground truth were eventually mapped into this 3-level taxonomy: false, in between, or true. So, for example, right? We have this sentence here from Barack Obama. Since 2009, we've cut homelessness among veterans by 1/3. Then a crowd worker's task here is to basically do some research and figure out whether this statement is true or not, or to what degree basically it is true. Per crowd worker, we also had a few extra variables from a questionnaire that each crowd worker went through. So for instance, we knew their party affiliation, their stance on different debated topics, also their confidence, for instance, regarding their fact-checking abilities. And this we used as a basis to kind of explore what cognitive biases may have taken place. Specifically, what we did was we went through the checklist, and every time we thought, okay, this cognitive bias might play a role here, we checked in this public data set whether we can find some exploratory evidence for this actually taking place. And based on that, we came up with 4 different hypotheses regarding cognitive biases in fact-checking tasks. The first concerned what we will probably refer to as an availability bias. So workers seem to just generally overestimate the truthfulness of politician statements, which could be the case if they just in general have a sort of idea in the head of politicians generally speaking the truth. Next to that, we found some exploratory evidence for an affect heuristic. So the more workers liked the statement claimant, so for instance, Barack Obama in the example I just showed, the greater the likelihood of judging the statement as true. We also found some exploratory evidence regarding a confirmation bias. So the more workers sympathized with the goal behind the statement, so the party affiliation, for instance, if they were Democrats, for instance, for the Barack Obama statement, their likelihood of judging the statement as true was a little bit higher. And lastly, we identified overconfidence as a potential issue here, which basically means that, and this is something we actually found in the exploratory study, that the greater workers' confidence in their fact-checking abilities, the less accurate their fact-checking actually was. So what we did is we basically tested these hypotheses in a new crowdsourcing study that had a very similar setup to how this public data set was collected. And what we found was the following. We did find an availability bias. Workers generally overestimated the truthfulness of politician statements. We also found evidence for an affect heuristic. So worker sympathy for the statement claimant was positively related to the likelihood of judging a statement as true. We did not find evidence for a confirmation bias, but we did find this overconfidence bias. So the more confident workers were, the less accurate, the worse their performance actually was. Quite counterintuitive result. So to take home, we think that requesters can use this cognitive biases in crowdsourcing checklist to assess, mitigate, and document potential cognitive worker biases in the tasks they design. And we hope that this can help requesters to basically collect more reliable, higher quality data. Regarding fact-checking tasks, we found evidence for availability bias, for an affect heuristic, and for overconfidence, which does not mean that these biases will always occur in every single fact-checking task or in every crowdsourcing task. It also doesn't mean that no other biases can occur. But I think what it shows is that going through the checklist, real influential cognitive biases can be identified, and this information can then later be used to well, mitigate them, or as I said, at least document them, and hopefully create some more higher quality data sets. Lastly, I just want to say that a lot more information, of course, in the 2 papers, and we also have an online repository where you can collaborate with us on the further development of the checklist, and you can find a lot of other nice supplementary material. That was my talk. Thank you very much.